Hello everyone. Today let me start the part 2 of laboratory reagents, that is assess the hazards. Okay. Now this assessing the hazards consists of three subdivisions: labels, inspections and risk assessment. Okay. Now what do you mean by assessing the risk of hazards? Students should be able to assess the risk of specific hazards. What do you mean by risk? Risk is the probability of suffering injury or harm from exposure to a hazard. Okay. Students should know the severity of a hazard and they must take certain precautionary measures. Okay. Now what is labels? Interpret the information given on a manufacturer's label or an in-house prepared label for a chemical substance. Use hazard information to prepare labels as per GHS. Now what do you mean by GHS? Globally harmonized system. Okay. So as per GHS for secondary containers. Locate the CAS. What is CAS? Chemical Abstract Service. Register number for a chemical. Identify the occupational exposure limits, that is OELS, using TLV. What do you mean by TLV? Threshold limit value. And PL. What is PL? Permitted exposure limit values. Differentiate between flash point and auto ignition temperature. Define and explain the relevance of upper and lower explosion limits for a substance. Now what is inspection? Conduct a laboratory safety inspection. Identify common safety concerns upon casual examination of a laboratory. Next, let us see what is risk assessment. Explain the process of assessing the risk from chemicals and chemical procedures. Okay. Prepare and explain a general risk assessment matrix. Risk and safety phrases are widely used and should be known by any user when handling chemicals in the course of laboratory procedures. Further information upon chemical stability can be obtained from Fluke brand F code. Okay. Now next is minimize the risk of hazards. Now this consists of lab clothing, handling and transport chemicals, fume food, safety and ventilation, handling glassware, waste disposal, and limitations of personal protective equipments. Okay. Now what is minimizing the risk of the hazards? Students should be able to identify ways in which the risk can be lowered. Okay. This may involve using appropriate engineering controls, administrative controls and personal protective equipment, that is nothing but PPE, to reduce or mitigate the hazard. Students should know common methods to minimize hazards and the limitations of those protective measures. Students must be aware that all laboratory research has risks and that careful planning and preparation can reduce those risks to acceptable levels. Students should prepare for emergencies by being able to explain how to respond to common emergencies that could occur in laboratories, such as fires, explosions, chemical exposures, injuries and chemical spills. Students should be able to explain the selection and proper use of emergency equipment such as fire extinguishers, eye wash stations, safety showers, spill kits, first aid kits, fire alarms and fire blankets. Okay. Students should know the importance of reporting laboratory incidents. Now let us see what is lab clothing. Clothing worn in the laboratory should offer protection from splashes and spills, and it should be easily removable in case of an accident. Okay. Non-flammable, non-porous aprons offer the most satisfactory and the least expensive protection. Lab jackets or coats should have snap fasteners rather than buttons so that they can be readily removed. These coats are to be easily worn and while working and removed prior to exit from the laboratory. Okay. It is highly recommended that no sandals or open-toed shoes shall be worn by laboratory personnel in the laboratory. Laboratory clothing should be kept clean and replaced when necessary. Now, what do you mean by handling and transport chemicals, and how do we handle and transport chemicals? Alright. Many laboratory accidents occur by carrying chemicals from one place to another or transferring them from one container to another. The chemicals used in a laboratory are often corrosive, toxic or flammable, and any accident involving these has the potential for personal injury. Therefore, it is good practice to assume that all chemicals are potentially hazardous. When large bottles of acids or solvents or other liquids are transported within the laboratory without a cart, only one bottle should be carried at a time. Okay. The bottle should be carried with both hands, one on the neck of the bottle and the other underneath. Do not hook a finger through the glass ring on the top of the bottle, allowing it to dangle while being transported. Never carry or attempt to pick up a bottle by the cap. Okay. Next, let us say fume hood safety and ventilation. General laboratory ventilation shall provide airflow into the laboratory from non-laboratory areas and out to the exterior of the building. Laboratory doors should remain closed except for exit and entrance. All reactions must be performed within a fume hood. The hood sash should remain closed or at minimal safe height while working in the lab. Okay. Now, let us see handling glassware. Glass breakage is a common cause of injuries in laboratories. Only glass in good condition should be used. Okay. Protect hands with leather gloves when inserting glass tubing. Hold elbows close to the body to limit movement when handling tubing. Conventional laboratory glassware must never be pressurized or used with vacuum. Okay. Now, let us see what is waste disposal and how to do it. Ensure proper segregation, containment and storage of waste. Okay. Miscellaneous and other contaminated solids waste such as papers, cottons, gloves, etc. Disposable plastic chemical containers should be collected separately. Sharp objects like broken glass pieces should be separately collected in appropriate containers. Okay. Now, let us see what are the limitations of personal protective equipment, that is nothing but PPE. Okay. Safety glasses do not protect eye area and face from chemical splashes. Next one is splash goggles do not protect from impact by solid material. Okay. Lab coats do not protect against flame. Aprons do not protect against hot liquids, molten metals or steam. Okay. Now, next let us say fourth part, that is prepare for emergencies. In that, first one is fire safety, Next is chemical spills. Third one is accident reporting, and fourth one is first aid. First aid for wound, chemicals in the eyes or mouth or skin, fire, breathing smoke or chemical fumes, burns, etc. Okay. First let us see fire safety. Fire is the most common safety hazard in any organization. Therefore, it is very essential for everyone to know how to survive a building fire and what to do in case of a fire. Okay. Let us see some common protocols and procedures that may be followed during a fire emergency. All right. Now, action to be taken in the case of building fire. On seeing the fire, do alert others by shouting fire, fire, fire repeatedly. Okay. Stay calm, do not give rise to panic. Judge the type of fire, use right type of fire extinguishers. Fire, depending on its origin, is classified as class A, that means combustible materials, that is wood, paper or furniture, etc. Class B, flammable liquids. Class C, flammable gas. Class D, metal fire. Class E, electrical equipment. Class K, oil greases. Use an appropriate extinguisher. Dry powder for all type of fire. Dry powder containing extinguishers are recommended to put off all types of fires. Okay. Carbon dioxide for B and C type fire, because the use of dry powder leaves a messy surrounding. Carbon dioxide based extinguishers are often recommended for small fire of chemical origin. Okay. Switch off power supply and AC units, inform substation. Another one is, do not fight fire if it is too large to control and atmosphere is toxic. Call for the help. Cover face or nose with wet cloth to avoid inhaling of toxic gas. Okay. Close doors from outside in case of severe fire to prevent the fire from spreading, and evacuate the premises. Do not use elevators for evacuation. Use only building staircase. Walk briskly. Do not run. Do not stop to pick up belongings. Give way to staff attending fire. In case of thick smoke filled room, do not walk. Instead, crawl with wet cloth covering nose and mouth. If fire breaks out close to a flammable gas supply or close to electrical power source, turn off the gas supplies and electrical power sources. Okay. If a solvent in a beaker catches fire, covering the beaker and depriving the beaker of oxygen can easily extinguish the fire than using a fire extinguisher on the same beaker, which may cause the solvent to spill, thus increasing the hazard. All right. If there are injured victims, provide the minimum necessary first aid only if you are sure that there is no danger to yourself. If providing assistance will endanger you, do not attempt intervention and move the victim immediately to the nearest hospital. Okay. In the case of emergency, call ambulance and then fire station. Chemical spills. Any chemical is a possible threat to your personal health and your friends. In case of accident causing the release of hazardous chemicals, a calm and determined action is required to prevent accident. Okay. For any individual incident, isolation of the spill or securing the area is best prior to contacting concerned personnel. This should be done according to all available information on the chemical nature of the spill. Under all circumstances, a laboratory coat, safety glasses and gloves should be used for self-protection. Alright. Always send for help first and report the necessary information like the place of incident, the chemical involved, injury to people, etc. If the spill presents an immediate danger, leave the spill site and warn others. Control entry to the spill site, remove contaminated clothing. Flush eyes or skin with water at least 15 to 30 minutes. Okay. Use soap for intermediate and final cleaning of skin areas. Then protect yourself and remove injured person to fresh air if safe to do so. If flammable vapors are involved, do not operate electrical switches unless to turn off motorized equipment. Try to turn off or remove heat sources if safe to do so. Turn off electrical at the mains, not at switches inside the laboratory. Okay. Where the spill does not present immediate personal danger, try to control the spread of the spill. Increase ventilation by opening closed fume hood sashes to full open position. Exterior doors may be opened to ventilate non-toxic vapors. Use absorbents to collect substances. Reduce vapor concentrations by covering the surface of a liquid spill with absorbent. Mop up the spill, wringing out the mop in a sink. Because of the health effects of mercury, extremely difficult and time consuming procedures are required to properly clean spills. Every effort should be taken to prevent accidents involving mercury. Always wash hands after handling mercury to prevent skin absorption or irritation. Always wear nitrile gloves while handling mercury. Okay. If mercury has been spilled on the floor, the workers involved in cleanup and decontamination should wear plastic shoe covers. Now let us say accident reporting. All injuries shall be reported to laboratory staff. Minor injuries many times are not reported because they are perceived to be embarrassing or that careless actions might have led to the accident. However, minor injuries can sometimes lead to more serious complications that only become evident at a later time. Taking corrective action as a result of a minor accident may keep a major accident from happening. Students should understand that the purpose of reporting and documenting accident is not to affix blame, but instead we should find the cause of the incident so that similar incidents may be prevented in the future. Okay. Now first aid. The first aid treatment of the type of injury which is most likely to be sustained in a chemical laboratory is discussed in this. Okay. Such injuries are caused not only by chemical substances, they often consist of cuts from broken glass tube or apparatus, burns from hot pipes or steam, etc. The treatment suggested must be considered as first aid. They are not a substitute for attention by a doctor or trained nurse. Any injury, however small, must receive prompt treatment. Delay may result in a minor injury becoming a major one. Okay. The first aid measures suggested are necessarily brief and they must be applied with common sense. For example, if medical attention is required, a doctor or an ambulance must be arranged at once. Okay. Now first let us see wounds. Wash your hands thoroughly before treating casualty suffering from a cut or wound, a burn or any eye injury. In all cases of skin, eye or mouth contact with an injurious chemical substance, thorough irrigation by rinsing with water should be the first treatment. Alright. Cuts or scratches, however small, should receive immediate attention. The wound should be covered as soon as possible with a sterilized wound dressing. If the skin around the wound is dirty or is contaminated with a water-soluble chemical substance, careful washing with clean water should be carried out. If the wound area is contaminated with a water insoluble chemical, careful swabbing with cotton wool and surgical spirit should be carried out, followed by the application of a dressing in the normal manner. Except in the case of small cuts or scratches, it is advisable to obtain medical attention as stitching of the wound may be necessary. Now, how to give first aid for chemicals in the eyes? Getting any kind of chemical into the eyes is undesirable. Some chemicals can destroy eyesight in a very short time. Flush your eyes with water in the eye wash immediately. Do not attempt to go to the office clinic before flushing your eyes. It is important that flush with water continued for a prolonged time, that is for about 10 to 15 minutes. While flushing is continuing, then arrange for medical attention. Okay. Now next let us see chemicals in the mouth. This kind of accident is usually unlikely. However, if it does happen, any chemical taken into the mouth should be spat out and the mouth rinsed thoroughly with water. Many chemicals are poisonous to varying degrees. If the victim swallows a chemical, note the name of the chemical and notify the teacher immediately. Dilute the stomach contents by making the casually drink 1 to 2 glasses of water and try to induce vomiting before poison specific expert medical help can be provided. Okay. Now next let us say chemical spills on the skin. For a small area, flush the skin with water first. For a small acid or base spill on the skin, neutralize an acid with dilute solution of baking soda. Neutralize the base with boric acid. For a large amount of chemical slipped on the body, use the safety shower. Caution: never apply concentrated acid or alkali to neutralize the corrosive liquid on the skin. Due to heat of reaction, matters can get even more complicated. For phenol, rapid and immediate skin decontamination is needed to minimize phenol absorption. Anyone assisting the victim should wear protective clothing and gloves. For small exposures, rapidly remove contaminated clothing and wipe exposed areas immediately and repeatedly with low molecular weight polyethylene glycol, okay, that is nothing but PEG. Treatment should be continued until there is no detectable odor of phenol. If PEG is not available, a glycerin solution can be used. If neither of these are available, irrigation with a source of high density drenching water will reduce phenol uptake, but lesser amounts of water will merely dilute the phenol and expand the area of exposures. For bromine on skin, wash a large amount of soap and water as quickly as possible. If eyes are burning or your vision is blurred, rinse eyes with plain water or for 10 to 15 minutes. Okay. Next is fire. A person whose clothing or hair catches on fire will often run around hysterically in an unsuccessful effort to get away from the fire. This only provides the fire with more oxygen and makes it burn faster. It is the responsibility of the teacher or the closest person to bring the fire blanket to the victim as quickly as possible. They smother the fire by wrapping the victim in the blanket. Tell them stop, drop and roll. Take medical help immediately. Okay. Next one is breathing smoke or chemical fumes. All experiments that give off smoke or noxious gases should be conducted in a well ventilated fume hood. This will make an accident of this kind unlikely. If smoke or chemical fumes are present in the laboratory, all persons, even those who do not feel ill, should leave the laboratory immediately. Make certain that all doors to the laboratory are closed after the last person has left. Since smoke rises, stay low while evacuating a smoke-filled room. Thoroughly ventilate the room before going back to work. Okay. Next is burns. Hold the affected skin under a stream of running water for at least 10 to 15 minutes. Keep the wound open and do not apply any ointment till expert medical help can be provided. In case of strong acid burns, after washing with water, rinse with dilute ammonia, that is 1 to 2% of sodium bicarbonate solution. It is a good practice that all employees should be provided first aid training and all should be familiarized with use of availability of safety gadgets. Senior members of the laboratory should hold periodically safety audits on proper function of safety gadgets such as fire extinguishers, safety fountains and eye wash stations. Okay. With this chapter is over. Please go through all the slides. Any difficulty, please contact me. Okay. Thank you.